In this video, we're going to look at U-substitution. So, let's see, U-substitution. Alright, let's go ahead and look at a problem. Say if we got the antiderivative of 3x squared plus 2x, and that's going to be in parentheses because it's going to be multiplied by e to the x to the third power plus x squared. Close the parentheses, and then dx. Now, looking at this problem, it looks menacing enough, but if we use something called U-substitution, where we substitute in the values for letters such as u, du, and dx, it makes it a lot easier to take the integral of it and then substitute back in the values. So let's see what I'm talking about. You can tell that this e to the u, the x to the third plus x squared, is actually what if you take the derivative of that, you actually get this value here, 3 to the x plus 2x. And this is a good indication of the ability of using U-substitution, because if you take the derivative of x cubed plus x squared, you get 3x squared plus 2x. So what we can do is we can take u and set that equal to x to the third plus x squared. We can take that equal to u. Now, if we did that, we'll figure that out, that du over dx is equal to 3x squared plus 2x. If we took the derivative of this, we would get that. Now, we can put it in terms as an integral by putting du by itself. So if we actually multiplied both sides by dx, the dx's here would cancel, so you would have du, let me write that on this side, du equaling 3x squared plus 2x dx. And when you look at this here, you can see in a way that it kind of looks at like the problem that we started off with, because we have 3x squared plus 2x and the dx here. So if you want, you can actually rewrite the problem as this: 3x squared plus 2x times dx times e to the x third plus x squared. It looks similar to what we started off with here. Go ahead and put that in parentheses. You can see that it looks similar to that. Now, we can actually go back and substitute and make things easier. So let's go back and substitute in some stuff to compress this problem here, to make it look easier. So let's say we go ahead and simplify it. So it's the antiderivative of e, and this here, remember we actually put u equal to x to the third plus x squared. So we're going to go ahead and just substitute that with a u. So it's going to be e to the u. And we know that this here, 3x squared plus 2x times dx, is du. So we can go ahead and just put times du. And now the problem doesn't look as menacing. If we went ahead and took the antiderivative of this, if we took the antiderivative of e to the u, which is almost the same thing as if you took the antiderivative of e to the x. It's the same exact thing. If you took the antiderivative of e to the x, you get e to the x. If you took the antiderivative of e to the u, it's going to be e to the u. So you have e to the u, and you have a constant. Because remember, we want to make sure all the numbers are accounted for. That's why we add a constant. The du goes away when we take the antiderivative, the integral. So we can go ahead and resubstitute back in stuff. Like, say, the u here. We can go ahead and resubstitute back in what we had u equal. So basically what we have is e to the x third plus x squared plus a constant. And that's your answer.